Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question 9, part 3 from the May, June 2022 Pure Mathematics P1 paper from Cambridge 9709. This is part 3 of the question, which is dealing with differentiation again and related rates of change. So I'm going to save this under that particular playlist. And this is question 4 from my end of topic worksheet. Now, this is 4 part C again. What I'm going to do here is I'm going to save this question under the playlist for this paper, for this end of topic worksheet, and also for the topic of related rates of change and differentiation. So it says a curve is such that dy dx equals 12 over 2x plus 1 squared, and P15 is a point on the curve. So here we have already been given the function already differentiated. This is the gradient function. It says a point is moving along the curve in such a way that the x-coordinate is increasing at a constant rate of 0.3 units per second. So this is a classic type of question dealing with related rates of change. Okay, so the x-coordinate is increasing at a rate of 0.3 units per second. So we can say the rate of change of x with respect to time, dx dt, is equal to 0.3 positive. If it said decreasing, we put negative in front of it. Okay, we say dx dt equals negative. It says increasing, so we're going to put it's going to be positive. So that's what's given. So there's always something given to us. There's always a given rate of change in these type of questions. And then there's another rate of change that we're always asked to find. So we're asked to find the rate of increase of the y-coordinate when x equals 1. So we're asked to find dy dt. We want to find what dy dt is when x is equal to 1. So when we want to answer a question such as this, we say dy dt, we write down what we have to find, equals, then we write down what we are given, which is dx dt, and then we think about what we have to multiply this by, such that we'll be left with what we have to find, which is dy dt. So what do we have to multiply dx dt by to end up with dy dt? Well, we want to have a dy on top, so we're going to write dy here, and we want to get rid of this dx, so we're going to put dx down here. Dx dt times dy dx is going to give us dy dt, because these two will cancel out. All right, so now dx dt, we know its value already is 0.3. And dy dx, we've already been given it as 12 over 2x plus 1 squared. So 0.3 times 12 is like 3 times 12, which is 30. I'll leave it like this. Why? It's going to be easy to deal with it. Like let's say that's 36 over 10 times 2x plus 1 squared, because that's going to be 12 times 3 is going to be 36, will be 3.6, right? That's 3 over 10. Yeah, okay. Leave it like that for now. Now we want to find dy dt when x equals 1. So when x equals 1, okay, because this is the x coordinate at the point P. So we're going to have 36 over 10 times, we're going to have 2 times 1 plus 1 all squared. So we're going to get 36 over 10 times, 10 times, that's going to be 2 times 1, which is 2 plus 1, 3. 3 squared is 9. So it's going to be 36 over 10 times 9. 9 goes into 36 4 times. So you've got 4 over 10, which is 2/5. Okay, so we can say that when x equals 1, the rate of change of y with respect to t is going to be 2 over 5 units, okay, per second. Units per second. Okay, I'll just write it in words like they have it. Units per second. All right, so that's the rate of increase of y with respect to t when x equals 1. All right, so that's the answer for question number 9, part 3. And that concludes this question. It concludes the whole of the question from this particular paper. Other questions from this paper, including part 1 and 2 of this question, can be found in the playlist for the paper, which will be over here. This section the end of the video. The link at the bottom right will be for the end of topic worksheet. So you'll find other parts of this question and the other questions from this worksheet in that playlist. And the playlist at the bottom here will be for the topic of related rates of change and differentiation. And I'll put a playlist here for differentiation in general of my P1 collection. Thank you for watching and see you soon.